Hey guys, this is 6-3 that we're going to be starting today. So you did solving by graphing, solving systems by graphing. You did solving systems by substitution. And now today we're going to still be solving systems, but now we're using something called elimination. This is my favorite one, elimination is. We'll see if you feel the same way about it or not, but I'm just going to talk you through the process of how you do this, and then we'll spend several days trying it and seeing if you like this one as much as I do. So first of all, when you are solving with elimination, you can either add or subtract your equations together, but I'm going to teach you just to always add, just to be consistent. If you would rather do subtraction, you are welcome to do subtraction as well and choose between addition and subtraction. But I'm just going to show you what I think is the easier one if you just are consistently doing it the same way. Ultimately, it's up to you if you would rather subtract than add, but I'll try to talk you through where things would be done differently with that. So in order to solve using elimination, you have to make your coefficient. Remember, a coefficient is the number that comes before the x or the y. So like 2 is a coefficient, 6 is a coefficient, 5 and -5, those are coefficients, okay? We want to make the coefficients to one of our variables, either the x's or the y's. Doesn't have to be all four, just the two x's the same or the two y's the same. But opposites of each other. So if one is a +5, the other one should be a -5 to eliminate it. Now that's using addition. If you're someone who is going to use subtraction as well, then it doesn't matter, then they wouldn't have to be opposites necessarily. So I will show you what I mean when we get there. And then step 2 is once we've done that, once we've made sure the coefficients are the opposites of each other, then we're going to eliminate a variable and solve for that other variable. So if you look at this first one here, okay, we have as coefficients a 2 and a 6. Are those the same number but just opposites, one positive, one negative? The answer would be no. If you look here, we have a 5 and a -5, and those are opposites of each other. So here's what I want you to think about. If I were to add 5y and -5y, what do I get? Well, I get 0, which means that my y's just went away because 0 times y is 0, okay? So that's what we're looking to do. We're looking to totally eliminate a variable in this situation. So if I take this whole thing and we go vertically with it, I'm going to add, okay, and I'm always going to add. Sometimes you might want to subtract here, and that's fine, but in this case, you would add regardless. I'm going to add these two things, these two equations together. So I'm going to start here, okay? 2x plus 6x is 8x. Then I'm going to go here. 5y plus a -5y is 0. So that goes away. Now, if it helps you to see a 0 there, that's fine. I think it's easier when it comes out to 0. I think it's easier just to leave it blank, okay? Because then what you're going to get is equal to, over here, if I add these two together, 17 plus -9 is 8. Well, notice what happens. This says 8x equals 8. Well, now we only have an x, and we know how to solve for x, right? If I take this and I divide by 8 on both sides, then my x is 1. Okay, and now from here, it's going to feel like substitution because we're going to take that x value and we're going to plug it into one of our equations. And it doesn't matter which one. You may plug it into either. I'm just going to plug it into the top one here. So I'm going to plug an x in of 1 right there. So that would be 2 times x, which is 1, plus 5 times y equals 17. So this is 2 plus 5y equals 17. I'm going to subtract 2 from both sides. So this is 0. and I'm left with 5y equals 15. And now I'm going to solve for y. Divide by 5, so y is 3. Okay, so my answer is when I take those two values and make them a point. 1, 3. Right, my 1 is my x, my 3 is my y. And that 1, 3 then is your answer. Okay, so you're just getting rid of the y's at the beginning, right? We just eliminated our y's up here so that we could solve for our x's with all of that information. Once we know what x is, then we plug it back in to solve for y. Okay? All right, so this one. If I want to be able to add these two equations together, right now I have 2x and 2x. If I add those together, I get 4x. But if I make one of those negative and add them together, then I would get the right value. So what we're going to do, so that we can add everything together, okay, just to keep it consistent, here's where you could subtract if you wanted. But the trouble with subtraction is when I subtract this, it's 4 minus a negative 2y. That becomes plus, and people always do that wrong. So that's why I don't do subtraction. If you want to do subtraction, excuse me, you may do subtraction. What I do is I just change the sign of everything. So in order to make this opposite, I'm essentially multiplying by negative 1. So this would be a negative 2x, this would be a positive 2y, and a positive 8. Okay, that's me multiplying every number by negative 1. It just changes the sign, which means now I can add these together very easily. So 2x plus negative 2x is 0, goes away. 4y plus 2y is 6y, and 22 plus 8 is 30. So we're going to divide by 6, and y will be 5. Okay, now from here, you're going to go back to one of your two equations. You may use either one. I'm just going to do the top one since we didn't change anything on the top one. You don't have to do that. I just think it makes more sense to me. So 2x plus 4 times my y value, which is 5, equals 22. So it's 2x plus 20 equals 22. We're going to take away 20. So we get, this is gone, 2x equals 2, and we divide by 2, so x is 1. Okay, so you have your x value and your y value. Your answer is the point where x is 1 and y is 5. Okay, so that would be your answer. Okay, that's the basics of elimination. Now it gets a little bit fancier because you're going to have to do a little bit of work to get to where you want to be here. So here's how it goes. Okay, if you look here, you have a negative 2 and a positive 7. Not the same number, not opposites, so that's not very helpful. Look here, we have a 15 and a negative 5. Not the same number, not opposites, but we want to eliminate one. So you have to ask yourself, what could I multiply one of my equations by so that I do get opposites? Well, negative 2 you can't multiply by something very easily to get 7. And 7 you can't multiply something very easily to get negative 2. But if you look here, a negative 5 and a positive 15, if we just take this whole bottom equation and we multiply by 3, I will get a negative 15, which is the opposite. Okay, so here's what I'm going to do. I'm going to rewrite this top equation right here, negative 2x plus 15y equals negative 32. And now I'm going to rewrite this bottom equation once I have multiplied everything by 3. Okay, you multiply everything. So once I've multiplied all of these by 3, I'm going to write what I would get there. So if I start here, 3 times 7x is 21x. Okay, 3 times negative 5y is a negative 15y. And 3 times 17. Don't forget this step. I know it's on the other side of the equal sign. You still have to multiply it. You're multiplying everything by that number. So 17 times 3 is 51. Okay, so here's my new system to solve. I always add because these are opposites. So I'm going to add these together. Okay, starting here. Negative 2x plus 21 is 19x. 15 plus negative 15 is 0. So that's going to go away. And then I have negative 32 plus 51. And that, don't forget your equal sign comes down here. Okay, that is 19. Well, now all I have to do is divide by 19 on both sides, and I get x equals 1. Okay, now this can get plugged back into any of your equations that you've used. So I would probably plug it into this one. I would do 7 times my x value, which is 1. Okay, I'm right here now. Excuse me. Minus 5y equals 17. Okay, so 7 minus 5y equals 17. I'm going to take away 7, take away 7. Okay, I'm going to move over here. So now I have negative 5y equals 10. And now I'm going to divide by negative 5. So y is negative 2. Okay, that means my answer is my x value, the 1, and my y value, the negative 2, as a point. So that would be a solution to that system. Okay. Okay, then it gets a little bit fancier still. So this is if you multiplied one equation. This one, you're not going to be able to do one equation. I can't multiply 3 to get 4 or 4 to get 3. And I can't multiply 2 to get 3 or 3 to get 2. So what happens here is you have to multiply both of them to get the same coefficient to both of your variables. So what I'm going to do is I'm going to multiply the top number by something, top equation by something, and I'm going to multiply the bottom equation by something so that I get coefficients that are opposites of each other. Okay, so let's look here. If I multiply the top by 3, okay, so that I distribute this, I'm going to get 9x plus 6y equals 3. Okay, now think about what would I have to do to this bottom then to make this cancel out with my 6y here. Well, right now this is plus 3y. So if I multiply by a negative 2, okay, and you can kind of see here, we multiplied by the number, but we had to put the negative in because we want to cancel out, but with addition, okay? So this would be negative 8x. This would be negative 6y. And this would be a positive 4. Negative 2 times negative 2 is 4. Okay, so now simplifying this, 9x, we're adding, right? 9x plus a negative 8x is x. This is going to be 0 equals 3 plus 4 is 7. Okay, so that's my x value. Now I'm going to take my x value and I'm going to plug it into one of my other equations. I'm just going to plug it into this one because it's the smallest numbers. So it's going to be 3 times my x value, which is 7, plus 2 times my y value equals 1. Okay, so 21 plus 2y equals 1. We're going to take away the 21. So you get 2y equals negative 20. And then we're going to divide by 2. So y would be negative 10. Okay, and that would be your answer. So you would get 7, negative 10. And that's your answer. Okay. All right, last one. This one's asking you how many solutions are there. So if I want to, oh, this is written wrong. Change this, you guys. This is supposed to be a 6. I don't know why I made it a 3. This should be a 6 in the problem. Sorry. So with this setup, if I want to cancel something out by addition, I need opposites, right? Well, if this is 2x, then I want this to be negative 2x. So I would have to multiply this whole thing by negative 2. Okay, so I have on top 2x plus 6y equals 18. On bottom, distribute this, you get negative 2x minus 6y equals negative 18. Well, notice what happens. If I go to add these together, remember we're adding all of it. So 2x plus a negative 2x, that's 0. 6y plus a negative 6y, that's 0. So I have 0 on the left. Okay? On the right, 18 plus a negative 18 is 0. So we get 0 equals 0. Where have you seen that before? You saw that in substitution, right? Where 0 equals 0. So this would be infinitely many solutions. Remember when the variables go away and you're left with a true statement, it's infinitely many, okay? If it ended up being like negative 1 equals 2, then you would say no solution. Okay, but for this one, it ended up being a true statement, 0 equals 0 or 10 equals 10. Anything that's true will be infinitely many solutions. Okay, so down here, this is just a flow chart of like, here's what you should be asking yourself as you do the problems. Can I eliminate a variable? Then do it. If I can't, then can I multiply one of the equations to eliminate? If you can, great, do it. If you can't, then say, okay, well then I must have to multiply both equations to eliminate something. So then you do it that way. Okay, so that's just kind of the process you're going through. Let me know if you have any questions, and we'll be covering this the next few days.